another tutorial again, and today we'll be looking at interpolation, conducting interpolation using the ArcGIS software. So for this particular tutorial, we'll be trying to look how we can be able to create this kind of surface interpolation, which can be used for geospatial analysis or for representation of data using ArcGIS. Okay, so this is what we are looking to create. And first of all, let's have an understanding of interpolation. So interpolation is a mathematical method for estimating unknown data points that lies between known data points, often used to fill gaps in data sets. So it creates a function or a curve that fits existing data, allowing for estimation of immediate values commonly in fields like statistics, engineering, and data analysis. So there are key types of interpolation. We have linear interpolation, we have polynomial interpolation, we have spline interpolation, we also have nearest neighbor interpolation, NNI. So these are the common uses of interpolation, the use case scenario. So one, it can be used for data analysis, so estimating missing values in a data set, and also geospatial stroke GIS for estimating elevation, rainfall, or temperature, and between weather stations. Okay, so image processing also for resizing images or rotating them by estimating color values between pixels. So let's dive into it. So this is what we are trying to create using ArcGIS, and let's look at what we are working with. So for us to be able to create this, we are looking at the rainfall data. So we're trying to create an interpolation to see the pattern of rainfall distribution within the northern Nigeria, which is our study area. So you see the values we have here. We have the stations where these weather stations are located. We have the latitude and longitude, their location, geographical location, and geographic coordinate system, and also have a rainfall data which are in millimeters. So that's what we are going to be using. So let's dive into it. So for you to be able to bring them in, is interpolation is more like using the points, these points you are looking at, which are our rainfall stations, to be able to estimate what the environment or the entire environment will look like using our GIS software. So let's proceed. So the first thing we are going to do is to click on File here, click on Add Data, and also Add XY Data. So after selecting this, we are going to locate our file. So this is my file. So if you have not created your working folder or you don't know how to get to it, you can start from folder connection and open up my GIS project or GIS tutorial, which is where I'm working, mapping, and this is your data, which is rainfall.csv. It's a command limited file format. Okay, so click on add, and the system is going to arrange them into longitude and latitude, where X is for longitude and Y is for latitude. So you remember that's your lines of longitude and latitude. Okay, so the next thing we are going to do, we are going to edit the coordinate system if it's not edited yet. But if you are working on your environment and you have defined your working coordinate system, it is going to appear here. But if not, you can click on edit, go down to geographic, scroll down to world, and scroll down to WGS 1984, which is our working coordinate system, and select. So after I've done that, we are going to click on OK, and you can see that the system have added these points where they should be. So you can see the points here. So the next thing we are going to do, this is still an event file from a database file, which is a CSV file. We are going to right click here, go to data and export. We are going to make it a shape file, which is a vector file format. So I'm going to drop here, go to my folder connection, and select my working folder, which is mapping, and I'm going to call it rainfall. So you can see that the save as type, which is shape file, and you're going to click save and OK. So the system is going to prompt this dialog box to ask you, do you want to add the exported data to the map as a layer? You say yes, and we have added that layer. So for your layer, you can decide to now style your layer by going to right clicking here, going to properties and symbology. You can click here and start styling your layer to suit what you want. So I'm going to make this one 9 and OK and OK. Alternatively, you can also do the same thing by double clicking on this point, and the system will open it up and you can be able to do it. Okay, so you can do the same thing from here. Okay, so the next thing we are going to be looking at is at interpolation. How do we interpolate these particular points to be able to have this surface. So the next thing we are going to do, we are going to go to our Arc2 box. If it's not, your own is not open yet, this is the Arc2 box. So if you click on here, you can be able to open or access your Arc2 box, which is where you almost all the analysis which you need to do are contained. So you can access it from there. So now that your toolbox is open, you are going to go down to this plugin, which is this particular analysis, which is Spatial Analyst 2. You click on Spatial Analyst 2, and you can see your interpolation. This is your interpolation. So under this interpolation, you have different interpolation method, or various interpolation method: IDW, Kriging, natural neighbor, spline with barrier, topo to raster, and rest of them, or trend. So for this, we are going to be using IDW. So we are going to open up the IDW, and it's going to ask us input point feature. So our point feature here is rainfall. So we click here and select rainfall to add our rainfall point. Okay, so it's added now. Alternatively, you can also come here, come to a table of content, hold and drag this to this place to add. Then it's going to ask for your Z value. So we are going to click here. Our Z value is the first column, which is the rainfall. So if I right click here and I say open attribute, you can see your first column, which is field 4, which is our rainfall data. So we are going to select it. And then for output raster, I really don't know why my Excel is showing me other columns, probably because I was working with other data. So this is field 4, and we are going to open the output raster. So under output raster, we are going to select our working folder. Because we have saved our file, we can see it at our home. Select it, and then we are going to call it rainfall idw.tif. Okay, .tif, and click save. And then the next thing we are going to do is this. You can decide to do your IDW to be like they run it like this. So when I press OK, you can see the system will analyze the IDW for me. So it's analyzing it. So it is done. So you can see the result of my IDW. You can see the shape of our IDW. So based on what I've asked the system to do, I didn't specify any other further command. So this is the result I'm going to expect from my multiple points. So, but if I want to have an IDW or an interpolation result that looks like this, look at what I'm going to do. I'm going to go back to the same IDW, and I'm going to select rainfall, and I'm going to select my value, which is field 4, which is for our rainfall data. I'm going to go to output, and under this output, let me call it IDW2. Let me call it rainfall IDW2 and save. So the next thing I'm going to do is I'm going to go to my environment. Under my environment, I'm going to click on processing extent, and you see default, we are going to select regional boundary. So you want to find out what my regional boundary is. I'm going to show you. Okay, let me go back and show you. So my regional boundary is the boundary of the entire region which I'm studying, the shapefile. If you use the state, you can see the state is demarcated, but this regional boundary is a continuous boundary that covers my entire workspace. So it's going to ask me for, I'm going back to environment, processing extent is going to ask me for extent. So I say I'm going to use regional boundary, and under this regional boundary, I'm going to also scroll down here, down to see and raster analysis. So if I click on raster analysis, I'm going to see other options. So you can see mask. So masks is like telling the system to only cut out the area which is contained within my study area. So I'm going to select mask, and the mask feature is going to be the regional boundary too. And once I'm done, I'm going to press OK, and I'm going to press OK. So the system will start processing the IDW. You can see it's processing, and now you can see. So this is our new, let me take away the old one. So this is our new IDW, or our interpolation result. You can see that it's well covered, and it expands across our study area. So this is how you can be able to run your interpolation. So you can also go further to customize your result by going to the symbology. You can decide to make it change the color also here, and you can decide to change the label because maybe you feel that there are too much values here. So I can say click on the label, click on format label, and select decimal places, and create two decimal places, and okay. So if I apply, you can see that my values are now into decimal places. So also I can also increase the number of classes to 10, and okay. I can also go to classify, and select to make it equal interval or natural breaks. So, but currently it's in equal interval, and it's 10 classes, and I'm going to press OK. So you can see the result of my interpolation. So thank you guys for watching, and don't forget to subscribe, follow, and comment. So we'll be in the comment section to respond to your possible questions, and don't forget to follow Spatial Toolbox. We keep bringing you insightful tutorials on ArcGIS and GIS as a whole. Thank you very much.